This is the second part of my video solution to our first formative assessment on this topic, evaluating algebraic expressions. And I'm going to work through the second problem here. Now, we do have two algebraic expressions right here, and we know they're algebraic expressions because they contain variables. And in order to evaluate an algebraic expression, I need to know what numbers I'm going to substitute in for those variables, and that's been given to us right here in the problem statement. So my very first step is to recopy this expression, but with the substitution. A is 2, and B is -3. And notice, I put the -3 in parentheses because I want to be really clear that I'm still subtracting B, but I'm subtracting a -3. So this is the way that the convention that we have for writing the subtraction of a negative number. Anyway, here we are. I have a subtraction, another subtraction, and an exponentiation. I have 3 operations. Normally, I would go for the exponent first because of my order. However, I've got some grouping happening here. Inside those parentheses is the 2 minus the -3. I have to do that subtraction first before I can raise whatever the result is to the power of 2. So I'll do that. 2 minus the -3 is 5. And so I did the subtraction, and now I'm down to 2 operations, subtraction and exponentiation. I often have students, make the mistake of trying to distribute this exponent. Oh, well, let me square the 2 and then square the -3. You can't distribute this exponent across subtraction. Our distributive property is the distributive property of multiplication over addition or subtraction. But it's the distributive property of multiplication over addition, not exponentiation over subtraction or any other operation. So also, you don't really need the distributive property for any of these because you can evaluate what's inside those parentheses, and you come up with just a single number. So anyway, let's just move on here. We have a subtraction and an exponentiation. I'm going to evaluate that exponent first. 5 to the second power, that's 5 times 5 is 25. And then I'm left with this subtraction problem. 5 minus 25, that just leaves me with -20. Over here, I'm just going to use the same values for A and B. Okay, so A is 2, B is -3, and I'm going to add the product of B, -3, times 2 squared. Now, I don't need all those parentheses necessarily, but it's just very clear and helpful when we're doing a substitution that whatever value we're substituting, we put it in parentheses. And that's very helpful here. If I leave these parentheses out, then I'm basically turning my multiplication into a subtraction problem, which is not acceptable. We're actually going to square this -3 and then do the multiplication, right? Because the exponent happens before the multiplication. And I'll also just point out that I have 2 terms here. And it's appropriate in this case to do maybe more than one operation on each line without getting confused. I hope that you can look at this expression, and we don't have any grouping happening. So we know that that addition is going to come after all the multiplication and exponentiation. So here we are. We know the addition is going to happen last. So I can do something to each of these terms and just save myself a little bit of space. In fact, I'm going to do that exponentiation first. -3 squared, 9. Still multiplying that by my 2. And then I'm going to multiply my -3 by 4, which is what I get when I square 2. 2 times 2 is 4. So now I'm down to 2 multiplications and an addition. And again, I can do this multiplication, and I can do this multiplication, and I'm still preserving the appropriate order of the operations. Now this addition problem, 18 plus a negative 12, well, that's like 18 take away 12, so that leaves me with 6. And that is my solution.